All right, so let's talk about identifying data couples. First of all, data couples do not always correspond to every single element of data in the actual system. You're really trying to highlight the data that's necessary to understand the structure of the software, right? How does control flow through the software, and what are the critical pieces of data that make that control flow possible, right? It's all about structure rather than understanding the process and data flowing. If you really need to understand how data flows, you should be looking at the DFD, right? Data flow is better done in a DFD than it is in a structure chart. That said, you do want data couples that are going to make the structure chart make sense in your structure chart. So probably you're going to look at the data flow diagram, and you should be looking mostly at the data elements rather than the data flows when you're doing that to create a structure chart. You want to pick out only the ones that are actually relevant for understanding how controls flows through the structure chart, or for understanding the architecture of the system, meaning the modularity of the system at a high level. Control couples are not easy to identify on a data flow diagram, in part because the data flow diagram isn't set up to show you where control messages would need to be sent. And so I don't think looking for control couples in a data flow diagram is particularly useful. They're really just messages or information that's necessary to determine how to perform an operation or to identify error conditions in the performance of an operation. And it's actually possible to make the control couples, make the structure chart more complicated by adding too many control couples for this sort of stuff. So I'd really recommend only using control couples where it's entirely likely that there would be an error in the interpretation of the structure chart, meaning essentially that you wouldn't be able to identify the modularity as clearly as you need to, because the structure chart is all about understanding the modularity of a system and the architecture of how that system fits together. It's not really intended to identify how data flows through a system or to identify how control flows through a system, because we have, unsurprisingly, the data flow diagram to understand how data flows through a system, and also, unsurprisingly, the control flow diagram to understand how control flows through a system. The structure chart is really just about the structure and the modularity of the system, so don't stress too much about identifying all of the possible control couples in your structure charts. We're really interested in modularity, so let's talk a bit about fine-tuning a structure chart to get the best modularity. We talked previously about the challenge of coming up with good modularity in software systems, and structure charts are essentially the first opportunity you have to express why you think your system is as appropriately balanced as possible. So the first rule in doing this sort of balancing is that no module should have way more data couples or control couples than other modules, right? You want to make sure that each of these modules, if there are data couples or if there are control couples, are relatively balanced. And that makes a big difference in terms of the modularity of the architecture in implementation. Again, you generally want to decrease coupling and increase cohesion. There are exceptions, right? But this is how design works. You typically want to have less coupling where possible and more cohesion where possible. And if it turns out that the architecture you've decided on at the very beginning of construction of your structure chart is not working, you should consider alternative architectures. It might be maybe the best advice here is it's easier to pull the ripcord and come up with an entirely different architecture than it is to fine-tune a structure chart into balance. So if you're looking at modularity as the number one thing in your structure chart, which many organizations do, alternative architectures may be the best approach that you could have. Okay, so let's look a little bit more at modularity in structure charts, because there are other terminology that you may need to know in order to communicate this modularity to people on the project. Factoring is one such term. It's essentially the notion of breaking up a system into modules. You're factoring it into the various different modules that you may need to actually better understand the architecture. And as you are doing factoring, it's important to think about span of control. And essentially this is a rule of thumb in design that no module should control more than 7 subordinate modules. 7 is the part that's a little bit hard to justify in the absolute sense, but from a heuristic standpoint, it's not bad. you're essentially looking for something reasonable here. The span of control needs to be reasonable, and 7 seems like a reasonable number most of the time. This is also sometimes referred to as reasonable fan out, right, or fan out instead of span of control. Both of those are acceptable terms, but whenever you're doing factoring, you want to keep in mind that you don't want to have too much span of control. You don't want to force some controlling module to have to control a wide span or a wide fan out of subordinate modules. This reasonable size piece is really critical. And while we're on that notion, don't create a structure chart that would require more than a single page or a single screen. If you do, you may want to actually have layered structure charts, so a module within a module, that in the same way that we have layered DFDs with a level 0 and then child diagrams associated with it. It's worthwhile to put vertical lines at the sides of reused modules, especially if you have layered structure charts where a module may be reused across multiple diagrams. Essentially, this is just creating an additional line on each side of one of those module boxes. This is critical because reusing code is one of the primary motivating factors for modularity, and if you have a system that really heavily depends on these reused modules, then those are design considerations that somebody's going to have to take into account when actually implementing this in code. Okay, so all of this talk about fine-tuning structure charts to achieve modularity and the terminology that's necessary for achieving modularity doesn't quite get us everywhere where we need to go. And this last piece, introducing some of the architectures, I think will bring a lot of that together and help you understand why we care so much about modularity in structure charts. These are structure charts. These are other ways that a structure chart could look that would describe a software system. The ones that I introduced and the ones that the textbook focuses on most are these hierarchical type structure charts where you have a sort of hierarchy of flow of control from top to bottom, left to right. That is also the case, the top to bottom, left to right, in a mediated structure and in a pipeline structure, although the pipeline is more left to right than top to bottom. But it doesn't quite work in the layered architecture, which is a valid architecture, a totally appropriate architecture. You can kind of think of the layered architecture as a combination of multiple hierarchical architectures that start in the center. So you might think of like this is a hierarchy, and then this is a hierarchy, and then this is a hierarchy. And each one could be interpreted from the center out and then left to right, or like counterclockwise. It's a totally valid approach to doing software development to interpret it this particular way. But I think the software architectures that are described in the textbook, these four, the hierarchical, pipeline, layered, and mediated, those are the most common types of architectures that you'll run into in industry. Pipelined architectures are very, very common for sort of synchronous processes, something that has to happen in this order, and it all happens in a synchronous fashion. Mediated processes are very common in architectures where you have asynchronous communications, and there's sort of buffering at each of these layers that could happen asynchronously. And then a layered architecture is often asynchronous as well, where you have communications coming in asynchronously from around the spoke, and they should not limit the central modules, the centralized piece of the system, from preventing them to continue operating on other layers when you're waiting for a response from one in particular, the way that a hierarchical system might, right? So like another way of saying that is if you consider this hierarchy as separate from this hierarchy, then they can each be doing things at the same time without having to have communication between one another. It's really just a matter of how do you communicate in that central node. All right, and then the last thing I wanted to say in this section is on program design process. If you have a DFD and you are really interested in just doing a program design, creating that first structure chart based on your DFD, you want to start with one process first, right? And then continue decomposing that into lower level tasks or statements. And eventually you'll get to the point where you have decision conditions that need to be defined about how are we actually going to implement this in software. This includes essentially error conditions, exception conditions, error flows if you're looking at a use case diagram. And after you have all of these design decision conditions outlined, you can hand it off to the programmer. Right? Especially if you're doing incremental iterative or some other version of iterative development within a waterfall lifecycle. But it's the error conditions and the exception conditions that really dictate this. As soon as you have a good reason to believe you've covered all the error conditions and you have identified all the exception conditions, at that point you've got the process is mature enough for you to hand it off to the programmers who are doing development.